Something we're going to do quite a bit here in chapter 3 is find the real zeros of a function. And zeros are the same thing as roots. So maybe you remember the terminology roots, and they're the same thing as x-intercepts. They are one of the most important concepts in algebra to be able to tell what's going on with the graph in terms of where it crosses that x-axis and where the x value is 0. So some common rules for how many zeros there will be. So for a polynomial function f of degree n, so that would be like if you just had f of x equals x to a power. So we don't know what the exponent is, so we say that exponent is n. Remember, a degree is an exponent. Okay. So when we reference n here, we're referencing the exponent. So one thing that's true is that the function, number 1, has at most n real zeros. So if this is x to the 3rd power, there could be at most 3 real zeros. And we say at most because some zeros are imaginary numbers, they're not real numbers. So it could be 3 or 2 or 1 or 0. So it has at most n real zeros. And then this we're going to discuss more in lesson 3-4, where we talk about the fundamental theorem of algebra, which helps us find the roots and how many there are. And then your graph is going to have at most n minus 1 turning points. And that means how many times does it change direction. And so if I have an x to the 3rd power, there would be 2 possible turning points. There doesn't have to be 2. Again, it says at most. And then those turning points are the relative maximum or relative minimum that we talked about in chapter 2. All right, so we know how to find zeros, even if it's not a quadratic. So to find zeros, let's make just a note off to the side here. So zeros, roots, x-intercepts, right? Those all mean the same thing. The first thing we're going to do in every single case, if it asks us to find those zeros, is we're going to try and factor. In factoring, the first thing you want to look for is greatest common factor. Okay. A lot of times there will be, sometimes there won't be. So GCF, we could try and factor into 2 binomials. If that doesn't work, if we have a quadratic, then we can use the quadratic formula. But remember, that only works if you have an x squared only. But we also have factoring by grouping. So don't forget about that. So here's some examples. Let's read through the directions. Find all real zeros of the function. Determine the multiplicity of each zero. So how many times is that number a 0? And determine the maximum possible number of turning points of the graph. So let's just go through those as we solve here. So letter A, we're going to go ahead and to find the zeros, we're going to take our function, set it equal to 0. I'm going to look at factoring first. So I notice that I can factor out an x squared. So we're going to factor out x squared and be left with negative, oh, you know what? We can also factor out a negative 2. We've got 2 as that leading coefficient. So let's factor out a negative 2x squared. So that'll leave us with a positive x squared and a negative 1 inside the parentheses. That equals 0. So here we have at most 4 real zeros. So notice I'm going to get 2 here and 2 here. There's my 4. So now I still do the same thing that I would before, and I take each piece and I set it equal to 0. So if we do negative 2x squared equals 0, we divide by negative 2, and then we take the square root. Now the square root of 0 is just 0. We don't do positive or negative 0, but because this is x squared equals 0, that means that 0 is a root 2 times. So x equals 0 is one of our roots, and the multiplicity, I'll write it out full here, is 2. That 0 is a root 2 times because it came from my x squared. So if you want to think about it, if it helps to think, well, normally with a square root, I would do plus or minus. There's my two answers. Because 0 is 0, we just say it's a root twice. It's not a positive or a negative. Okay, so let's go ahead and solve this other side. So x squared minus 1 equals 0. Add the 1. Square root. Now in this case, because I'm not taking the square root of 0, I'll have a plus or minus. So x will equal a positive 1 and a negative 1. So in this case, these are two different answers. So I would say x equals 1 has a multiplicity of 1, because that's one of the answers. And then x equals negative 1 also has a multiplicity of 1. And you may also see the terminology that it's even or odd multiplicity. So a multiplicity of 2 obviously would be even. A multiplicity of 1 would be odd. So you might see that terminology as well. So there's what it's asking us for. And then it's also asking us for the maximum possible number of turning points. So let's answer turning points. And remember, that just comes from n minus 1. So our n value, our largest exponent here is 4. So we would do 4 minus 1. So turning points would be 3. So 3 possible turning points. So that's where they change direction. All right, let's try letter B. So letter B, we have an x in every term, so we can factor out an x. Set that equal to 0. So that would give me x equals 0, and that's only 1. So that multiplicity there would be 1. And then my x to the 4th term here, my trinomial, I can factor that, or try to. X squared and x squared. To get 6 and 1, I could do 3, positive 3, negative 2. So in this case, I'm going to set each one of those equal to 0. So here. Now in this case, I'm taking the square root of a negative 3. This is not a real number. So this is not going to give us a real 0. So here's an instance where we can solve, but we get an imaginary number. That means that visually on our graph, we will not see a 0 at that point. If you did a 3-dimensional graph, that's when our imaginary numbers can be shown. But we're not going to worry about that. So in this case, square root of a negative number, we cannot do. So that's not a real 0. And then if we do on the other side, oops, x squared minus 2 equals 0. Add the 2. Take the square root, and we can take the square root of a positive. Now this one's not going to give us a whole number, which is fine. Plus or minus root 2. So if I split this apart, and if I were to graph this, I would want the decimal. So I would say that x equals positive root 2, which is about 1.4, and x equals negative that, so negative 1.4. And each of these have a multiplicity of 1. And the other thing we need to know is the turning points. So how many turning points would there be here? With a maximum number of turning points. My exponent is 5, so 5 minus 1 would be 4. So here are my zeros. Each one of them has a multiplicity of 1. I have 2 that are not real, that's fine. And then there's a possibility of 4 turning points in that graph. All right, one more. So in this case, we do not have a greatest common factor. Well, we have 4 terms, and 4 terms is our key to look for factoring by grouping. So if we group the first 2, group the second 2, in the first set of parentheses, I can factor out an x squared. And in the second set, I can factor out a negative 25. So I'll leave us with a positive x and a negative 4. Set that equal to 0. Finishing that factoring, we can factor out that x minus 4. and it leaves us with the x squared minus 25. So in this case, we started with an x to the third power. So there's 3 possible zeros. There's 2 possible turning points. So if we set each piece here equal to 0, x equals 4 is a 0 with the multiplicity of 1. There's only one of them there. And then x squared minus 25 equals 0. Square root there is a nice perfect square. So we get positive 5, negative 5. Remember, those are 2 different numbers, so each of those also only has a multiplicity of 1. So we got 3 zeros, and then our turning point, like we said, could have 3 minus 1, which is 2 of them. So there's some practice finding your roots using any sort of factoring. The multiplicity of each root is just how many times it occurs, and how many turning points there are is your largest exponent minus 1.